Good morning, everyone. So today we have chat also. So dear students, we will compile today the chapter number 18. Tomorrow I will provide you on your Facebook link one the revision exercise, and we have already discussed the graph of various functions, your linear function, quadratic function. We have discussed the graph of reciprocal function. Today we will discuss the graph of exponential functions. So we have the students uh, those who are sending their homework. I want to appreciate Deepak and Puneet. They are regularly sharing their homework, and it's my request to other students also that you should complete your work and the worksheets, the assignment regularly, because we have the final dates for our final examinations, which are in the month of October, and I think 23rd and 25th. So work hard and attend your all classes, be punctual, and practice more and more mathematics, more and more sums. So in the next class, we will start the chapter number 19, that is the function. So today we have discussed about the graph of the functions. If we have the function, linear function, then on the graph we have a function like fx, or like here we have like 3x plus 2. So it is a linear function. Here the degree of a variable is 1, and always remember, for the linear function, if 3x plus 2 is equal to 0, this implies that x is equal to minus 2 by 3. If we plot the graph of a function, if we have a function fx is equal to ax plus b, where a and b are the coefficients, then for ax plus b, the solution always x is equal to minus b upon a. What I want to tell, that there is a relation of the zeros of the function, means the solution, that is the for linear function, that is minus b upon a. Here we have any other polynomial, that the function, that is fx is equal to your 7x plus 3, then the solution will be minus 3 by 7. Or if we have a function like fx is equal to your 5x plus we have like 10, then we plot the graph of this function, we will find that the line will minus of, that is minus b upon a is equal to minus 2. So its graph will definitely pass from this point, and this is the solution of this linear function. Similarly, for the quadratic functions which we have studied in detail, right? So let's start our the next graph, that is the exponential graph. I hope you have solved your previous exercises 18.4 and 18.5. We have left with 2-3 exercises. Try to complete chapter number 18, a complete work, and I want to make the complete record. So be sincere and comes to the exponential functions. The function y is equal to a raised to power x is called the exponential function. Let's take the working example here. We have plot the graph of the function. Plot the graph of the function. Function y is equal to 2 raised to power x. Y is equal to 2 raised to power x. So here we can make a table, and here range is given. For the value of x, the value of y. So here range is given minus 3 to 3. X is greater than or equal to minus 3 and x is less than or equal to 3 here. So here minus 3 x is 1, then y is 2. X is minus 3, the value of y, that is 0.125. So how here if x is equal to minus 3, then y is equal to 2 raised to power minus 3, which is equal to 1 upon 8. So you can use calculator to find these values also. So we have, that is 0.125. Next we have minus 2 here. So putting the value x is equal to minus 2, that is 0.25. So here next we have the value 1. So here that is 0.5. When it is 0 here, so value is, this is very important, when x is equals to 0. For exponential function here, when x is 0, so y is equal to 2 raised to power 0, which is equal to what? This is very important. Please remember, if we have a number a raised to power 0 is always 1, x raised to power 0 is always 1, 5 raised to power 0 is always 1. Any constant raised to power 0 is always 1. So here, when the x is equal to 0, when x is equal to 0, y is equal to 2 raised to power 0, that is y is equal to 1 here. Next, x is 1, y is 2. When x is 2, y is 4, x is 3, y is 8 here. So I hope you are clear with this exponential function table. We have taken the range from -3 to 3 and the values are 0.125, 0.25, 0.5, 1, 2, 3, 1, 2, 4 and 8 respectively. So dear students, now draw the graph, and on the graph this is x-axis and this is y-axis. As good morning Puneet, good morning Muskan, good morning. There is one person Sahil, but anyhow, I think fx is y. Yes, fx is. We say fx is y. Function is y. We can write y as a function in terms of x, or y is fx, one and same thing. So here the values are, because these are the point, we have to take 1, 2, 4, 1, 0 here. So on. So when we have x is -3, x is -3, y is 0.125. So it is very close. It is very close. Y is near about here. Y is, now when x is equal to -2, x is equal to -2 here, y is 0.25. So 0.25 is 0.5. This point, this point is 0.25. When it is 1, so here we have, when x is 0, y is 1. X is 0, y is 1. And when x is 1, y is 2. X is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. So here we can have the graph of this exponential function from here the graph of the exponential function here. This is 2, 4. This point here is 1, 2. This point here is x is 0 and y is 1. This point here minus 1 and it is 0.5. So on here 2 and 3. So this is the function of this graph of this function, that is y is equal to 2 raised to power x. So we have here exercise 18.6. We have the graph of 3 raised to power x. We have 3 raised to power x. We have next question, that is y 1 raised to power x. So same way we can plot the table. Range is given. For first question, the range is minus 3 to 3. For all question exercise exercise 18.6, the range is minus 3 to 3. For all questions we have question number 1. This is question number 1 here. Question number 2. So we can solve these questions one by one. To find the values, you can use the calculator also. And plot the graph first, table and then the graph. So we have next, that is the next topic, that is the gradient of the curve. So what is the gradient? At particular point, that is the slope of the tangent, that is the gradient. That is the gradient of curves. As we have studied in the coordinate geometry also, the gradient, when we find the gradient, that is y2 minus y1 upon x2 minus x1. I have discussed earlier also. We have that straight line graph. We have 2 points. Then here this point, it is your x1, y1 coordinates, and this point is your x2, y2. Then the gradient at y2 minus y1 upon x2 minus x1 is the gradient. So if we have plotted the graph of a function, so we can find the gradient of that function y is equal to, for the function y is equal to 2x square. For the function y is equal to 2x square, calculate the gradient of the curve at the point x is equal to 1. Find the gradient of the curve at the point x is equal to 1. So here we have already in the exercise, we have this kind of questions. If you plot the graph, plot the table. So here y with -3, -2, -1, 0. Then we have 1, 2 and 3 here. So here when x is -3, so here y is equal to, so we can, I am directly taking the values from the book. But the graph here, the plotted graph, that is -1, 2. When we plot the graph here, here the points here are they drawn, that is 1. So here they have taken not in this way, that is 2, 4, 6, 8, 10 and 12, and the values here after substituting the values, they have started here with graph 1 is at 1 and 2, and then we have -2 and 8, -2 and 8 here. Similarly here 2 and 8, and next we have, that is 3 and 18, that is 3 and 18. So 3 and 18 here. For this graph, at 0, this is the graph of this function y is equal to 2x square. Now at x is equal to 1, at x is equal to 1, here this is the x1, the value of graph, this point on this dotted line, the value of x or abscissa, that is 1. So this x is equal to 1. Here this point we want to draw one tangent. So we will draw with the help of scale one tangent here. And at this point, let this point is A here, if we want to find the gradient of this graph at this point A, then this gradient G is equal to y2 minus y1 at x2 minus x1. We can choose any point on this tangent. This is a tangent to on the graph which is touching the graph at point A. A is called the point of contact. Here, if A is equal to 1 and this graph, this point A is called point of contact. So we can take any point like BC, what is the x1, y1, and another point x2, y2, and we can find the value of the gradient. So here they have find one, they have chosen 2 points. One is 0 minus 2 here. Sorry, they have chosen this way. Here 1 point in the book, that is 0, x is 0 and y is minus 2, and here they have chosen 1 point, that is 3, and we have to check the graph. So here the another point is 3 and 10. So 1 point is 0 minus 2, and another point is which is taken in the book, that is 3 and 10. One is x1, y1 and another is x2, y2. We can choose any one. So this line is having infinite many solutions. This line, every line, straight line is having infinite many solutions. We can take any 2 points. Any 2 points on the line, one has one coordinates as x1, y1 and another as x2, y2. So the gradient here if we have, that is 3, that is x1 here, that is y1, and it is x2, y2, or this is x1, y1, whatever you want, you can change. That is x1, y1, and here x2, y2. It hardly matters because these are the variables. So here 10 minus 2, 10 minus of minus 2, and here we have 3 minus 0. So we have 12 upon 3. So the gradient of the curve, that is 4 here. So I hope you are clear with the gradient of the curve, and half is Puneet Pal, half of 0.25. Half of 0.25. Half of 0.25, that is 0.125. If we want to half of 0.25, that is 0.1, that is 25. So it is from Puneet. Okay, you have discussions. So focus here. Puneet, sir, I had not asked. I have to just focus on the. If you have a genuine thing to ask, okay, you can WhatsApp me. This is my number 750